Hello everyone. Today in this video we'll see how the slump test on concrete is performed according to ASTM C143, ASTM C143M. So myself presenting you this video. I am Bharat. I am a grad student at Iowa State University. So what is a slump test of concrete? So it's a test that measures the workability of concrete in its fresh state. So there are two keywords here, workability and fresh state. So what's workability of concrete? So workability is the amount of effort that you need to put in order to work with your concrete. So what do you mean by working with the concrete? So it's basically how easy it is for you to change the shape or mold the concrete into the required shape, compact the concrete and place at the required location. So if you are supposed to put a lot of effort to do any of these, to place, to compact, to work with it, so if you are required to put a lot of effort, that means you have a less workable concrete. So on the other hand, if you are required to put a very less effort, if you are able to work with your concrete easily, that means you have a better workability of your concrete or a better workable concrete. So fresh state. See, the concrete that you prepare can be in two states. When it is newly made, when it is still wet, it's called fresh state of concrete. So if you leave it for some time, after you prepare your concrete and you leave it for some time, it hardens. So that will be the hardened state. So basically this slump test measures the workability, amount of effort that you need to put to work with your concrete when the concrete is still fresh. Also, it helps to know the consistency of the concrete used. This is one of the tests. Slump test is one of the easiest and the simple tests that is used to measure the consistency or to know the consistency of the concretes used. Suppose you have different concretes or different batches of concretes that is made. So you can use this test to see how consistent are you in preparing your concrete mixes. This test is also helpful to check the quality of the concrete inside. So this is one of the simple tests again. So this is one of the very simple tests that is used across all construction sites to measure the quality of the concrete. It's a simple test. So it is also helpful to check the consistency between the batches of the RMC. So what's RMC here? RMC is the keyword. So RMC is ready mix concrete. So basically it's a concrete that is already readily made in RMC plant. Suppose you want to have some concrete at your construction site and you know what concrete you need. So depending on the requirement and your specification, ready mix concrete plants can produce the concrete and supply it to your sites. So here is a small picture of a truck. You might have seen all these trucks, this type of trucks that go on roads. Basically these are transit mixers. So these are the trucks that ready mix concrete plants use to supply the already prepared concrete to your construction sites. So these 4 points are the main uses or the primary uses of the slump test, and there are various other uses as well. We'll see this in the next video. So coming to the table at the bottom of the slide here. So why this test is important? This is just an example of why this test is important. If you see here, depending on the purpose of the concrete or where you want to use your concrete for, or what you want to use your concrete for, there are various required or recommended slump values. Suppose if you want to use your concrete for the reinforced foundation walls and footings, the recommended slump is in the range of 1 to 3 inches. So minimum 1, maximum 3. So there is a limit for the slump. You cannot have lesser than this limit or greater than this. So there is a recommended slump based on the type of construction that is intended using your concrete prepared. So this table I have taken it from Mehta and Montero. So the concrete, one of the good books for the concrete technology. So coming to the test apparatus, what do we need for this test? So this is the entire setup. So primarily we need a slump cone. It's also called mold. So you can see the mold has 2 handles to handle it, to work with it. So there is a requirement of the base plate. So base plate is primarily required because if any concrete falls out of your slump cone, we are able to capture it. So there is no wastage. So we need a funnel which helps to pour the concrete into the slump mold. We need a slump rod, or it is also called tamping rod, to compact the concrete inside the slump cone. We need a ruler or a scale, you can call. We use it to measure the slump value in millimeter, inches or centimeter. So we need other accessories such as scoop. So we need scoop to pour the concrete into the slump mold. We need wire brush to clean the slump mold after the test, and other tools that are used for the testing, and we need trowel. So this is the schematic of the test setup taken from ASTM C143 standard that we are following. So above this yellow dotted line, you can see the top view of the setup slump cone, how it looks. So there is a hollow portion, and the bottom of the slide shows you the side view of the slump cone. So there is an opening at the top and bottom. So there are two openings, one at the top and one at the bottom. So the top opening is 100 millimeter, the bottom is 200 millimeter, and the height is 300. So 100, 200, 300 is the dimension of the slump mold. And there are two handles which is helpful to lift the slump mold during the testing. So this slide shows the simple test procedure in these simple 6 steps. So at first, the concrete that you need to test for or use for the slump test, you pour the concrete into the slump mold in such a way that the height of the concrete that is poured is 1/3 of the total height of the slump cone. Then you compact the first layer, which is 1/3 of the total slump cone height of concrete. Compact this layer using the tamping rod 25 times. So after you are done compacting 25 times, pour the second layer of concrete. Again, the thickness of this second layer will be 1/3. Now the total concrete that is poured into the slump mold is 2/3. So initial first 1/3 layer and the second layer of 1/3 height. So pour the second layer and compact it again using the tamping rod. So give tamping of 25 times. Give 25 times. Tamp 25 times. Sorry. So now you should pay attention. So while compacting the second layer, now compact the second layer in such a way that the tamping rod penetrates 1 inch into the bottom layer. Then after you pour the second layer and give 25 blows or 25 tamping, then pour the third 1/3 layer such that the slump cone is filled. So make sure that you overfill the slump mold in such a way that there is an excess concrete at the top. Then give a tamping of 25 times. Now make sure that you penetrate 1 inch into the second layer, that is the bottom layer. So after you are done compacting 25 times, remove the excess concrete using a strike off bar or use the same tamping rod and remove the excess. Then now carefully remove the slump mold vertically upwards. Here you should pay attention because you are supposed to lift the slump mold smoothly vertically upwards. So don't drag it horizontally. Don't drag it horizontally, or don't give a jerk. It should be smooth. And finally, let the concrete come down by its own weight. And then the distance between the initial height of the concrete and the final height of the concrete is taken as a slump, which we'll see here. So this is the slump that is measured. So initially, before lifting the mold, there was the initial height. So initial height. So after you remove the mold, the concrete might come down or might not. So if it comes down, we will have a second height, that is the final height. So the distance between the difference of the heights, difference of the initial and the final height is taken as the slump value, which is expressed in millimeter, centimeter or inches. So here, so do's and don'ts. So what you're supposed to do. So here many people use something like this. There is a the base plate can be like this with a, as shown here, with the handle. Some people use this handle to measure the slump, so please don't do that. So don't do this. And what you're supposed to do is, so invert the slump count that you used, or the invert the slump mold, then place the tamping rod and measure the difference in the heights. So do this and don't do the previous one. So what are the types of slump that you might come across? So depending on the type of the concrete that is prepared, your slump might be any of these. So if the concrete does not come down, that means you have a zero slump. The difference between the initial height and the final height is zero. The concrete has not subsided or not come down. It has not come down. So that in that case you will have a zero slump. So the true slump is what we saw in the previous photo, previous slide. Okay, it would be something like this. So it comes down. So you measure the difference. So in this example it is 5 inch. So sometimes you can have a shear slump. So basically one portion of your concrete might fall down or shear off, and the other concrete, the bottom concrete, remains intact. So in this case, this is a shear slump, or the concrete might collapse. When your concrete has a large or a greater slump, so as here, as indicated here, 6 to 10 inches or 150 to 250 millimeter, in such a case you will have a collapse slump. So you can come across any of these types of slumps in your concrete depending on what type of concrete that you have prepared. Okay, finally, to see, there are some factors that affect the slump. These are some of the key factors, and there are various other factors as well. So one is the primary factor that affects the concrete slump is the water content and the cement content. So basically both of these are combined in a factor, water to binder ratio or water to cement ratio. So water to cement ratio affects concrete slump. And the aggregate characteristics. So the properties of the aggregates that you use in your concrete affects the concrete slump. So admixtures such as mineral admixtures and chemical admixtures might affect the slump values. So mineral admixtures, what are mineral and chemical admixtures, we'll see in the next video. And there are various other factors as well. Thank you for your patience, and thanks for listening to my video. If you have any questions, please write your questions in the comment section below, and I'll try to answer it. And if you'd like to hear me talking about any particular topic, please comment below. And also don't forget to subscribe to my channel. Thanks.